Notes, everyone can hear me? Perfect. All right, so 5, 7 systems of linear equations. So this is very, very similar to what we did the last two classes. We're now just going to be doing a system, which means we're graphing two lines at once. If you are someone who likes to color code or likes to shade with like highlighters or colored pencils, I highly recommend getting two colors out if you can. If you want, you don't have to. It's not required. It's just sometimes nice just to kind of have some visual help with this. So a system of linear inequalities is a set of two or more linear inequalities. So we're going to have two or more equations. For this class, just two. So you might see something like this, like y is less than x plus 2, and y is greater than or equal to 2x minus 1. So what we're going to be doing is graphing both equations. And before, we were graphing both equations and seeing where they crossed. This time, we're going to graph both equations and see where our shading overlaps. Because before, we would graph our line and shade, right? Now we're going to be doing that twice. And kind of like our answers are where the shading overlaps, which is why if you want, it's helpful to have two colors sometimes. So the first thing we're going to do is just practice plugging in points and seeing if they work or not. Now, remember, when you have two equations, is it okay if a point just works for one of them, or does it need to work for both? Alex says 2. Do we agree? Does it need to work for both? Yeah, definitely needs to work for both. So we're going to plug this in. So remember, we need to put the x, which is our 3, where we see x's. And we're going to put the y, which is 5, where we see our y's. We're just going to do one equation at a time. So I'll erase this bottom part so you guys don't get thrown off. So we're just going to plug our x in where we see x and our y in where we see y. So for this first equation, we're going to have 3, because that's where our y is over here, is less than 2. And then next to that 2 is an x, right? So I'm going to put my open parentheses, and in place of that x, I'm going to put the number. Oh, wait, what did I do wrong? Do you guys see it? Uh-oh. Thank you, Aiden, I did. Yeah, I did. I messed that up. So I was too focused on my color coding and not enough on my letters. I'm also like very awkwardly hovering over my computer right now. So this should be a 5. And then so 5 is less than 2 times your x, and your x is 3. Okay. So now how can I simplify this? What should I do? What needs to be simplified? Yeah, I'm going to distribute. 2 times 3 is 6. So we're going to have 5 is less than 6. Is that true? Is 5 less than 6? You don't think so? No? What do we think? Thumbs up, 5 is less than 6, or thumbs down, 5 is not less than 6? Oh yeah, no, good. Thumbs up, 5 is less than 6. See, isn't that so much easier? Then I don't have to be like, Hayden, is 5 less than 6? And then no one answers me. Now you can just tell me. I think so, right? Then I don't have to be like, I don't know, you can just thumbs up or thumbs down me. All right. Sometimes I'm going to ask you a direct question still, but then if you're like confused, you can kind of like look at me panicked instead, and I can help you then. All right, so 5 is less than 6, definitely. So now we got to check it in the other equation. So now we're going to check it in this bottom equation. We need to put 5 where y is and 3 where x is. So we're going to have 5 is greater than or equal to. So 5 is greater than or equal to x, which is 3, plus 1. That's just the rest of our equation. All right, what can be simplified here? Any ideas? Yeah, do you guys see like any addition, subtraction, multiplication, or division anywhere? Addition, yeah, we have 3 plus 1, so we can simplify that. 3 plus 1 is 4. Is 5 greater than or equal to 4? Yep, that's okay, Asia. All right, so this one works for both. So if it works for both, do we think it's good or is it not a solution? Yeah, I think it's good. It is a solution. So we would say solution. All right. Asia, you really just missed the first one. We're just plugging in coordinate points. All right, so number 2, we have that x is -1 and y is 5. So this one I'm actually going to use my highlighter. That's a little easier. So x is -1. So I'm going to plug that in anywhere I see an x, which I only see one in the second inequality. That's okay. And then the plugging in both, no, but you'll probably have to do it where you plug in just like one into one equation. So it's good practice. And then put your 5 where you see y's. So let's try it in this first one. So this first one is just y is less than 5, right? So I don't have to even worry about x. Y is 5. So all I need to do is rewrite 5 is less than 5. That's for this one right here. All right, I just plugged that in. What do we think? Is that true or false? Is 5 less than 5? That is false. If it had the or equal to underneath, it'd be good, but it doesn't. So that is incorrect. I'm going to put a little x next to it. Well, I guess the x might look too much like a variable. I'll put a little like slash through it so we can see this does not work. Okay. So now let's try the second one. So now we're going to look. Oh, yeah. You're right, Alex. Do we even need to continue? No. Didn't work in the first one. If it doesn't work in the first one, who cares if it works in the second one? We're going to say not a solution. Good call, Alex. I was just being a robot, automatically plugging things in. Good call. I've taught you things. I'm so proud. All right. So for number 3, we got 0, 0. And we have y is less than or equal to x plus 7, and y is greater than or equal to 2x plus 3. So we just got to plug zeros in for x's and zeros in for y's. So that should be pretty easy to remember. What was that, Alex? The y will be greater than or equal to 3. So yeah, you're probably right. It's probably not going to work, but let's double check. So let's take a look at this first one. We're going to have a y, and y is 0, so we're going to have 0 is less than or equal to 0 plus 7. And remember, anywhere you see adding, subtracting, multiplying, dividing, make sure you simplify that. Over here on the right, we're adding, and 0 plus 7 is still just 7, right? Nothing changes. Is 0 less than 7? Definitely. 0 is less than 7. That one works. So that's good, but we need to now see if it works in the other one. We need to see if it works in y is greater than or equal to 2x plus 3. So y is 0, so put that in, is greater than or equal to 2 times 0 plus 3. We got a little bit extra to simplify over here. What should I simplify first on the right? Should I multiply or should I add? We need to multiply, yeah. So 0 is greater than or equal to 2 times 0 is just 0, right? And then I got to simplify one more time. We got 0 plus 3, which is just 3. Is 0 greater than 3? No. So that is not going to work. So if it works for one of them, but it doesn't work for the other, what would we say? Yeah, that is correct. Not a solution, or you could say no solution. Not a solution. Good. All right. Last one, then we'll move on to some graphing. I don't know why this one's kind of lined up weird. I don't know, the spacing got all messed up. So with this one, we got that x is 1. So we're going to plug that in everywhere we see x. And we have that y is 4. So we'll plug that in where we see y. So let's take a look at this first inequality. We got y is greater than or equal to 3x plus 1. So somebody help me out. How do you think I could plug this in? Because I'm writing it down for you, but I want to make sure we know where to put everything. Good. 4 thingy, greater than or equal to, yeah. and then you said 3 what? Yep, very good. 3 parentheses, 1 in the middle. Look at you go, Alex. 10 out of 10. Killing it. All right, so now we can simplify. So make sure, I think we're pretty good with this part. Simplify our multiplication first. 3 times 1 is just 3. So we're going to have 4 is greater than or equal to 3 plus 1. And then one more time, simplify over here. 3 plus 1 is 4. What do we think, guys? True or false? Is 4 greater than or equal to 4? Definitely. Yep. Good. All right. Let's see now with this second one. Now we got y is greater than x minus 1. So somebody else, how do we think we could plug this in here? Any ideas? Very good. 4 is greater than 1 minus 1. Thank you. And here we only got the one thing to simplify. We got some subtraction over here. 1 minus 1 is just 0. Is 4 greater than 0? Yes or no? Definitely. So if they both work, what do we say? Yeah, we say that it is a solution. Very good. Good. All right. Questions about that? I'm sure there will be at least one on the test that you have to plug in a coordinate point for, but it might not be a system one. It'll just probably be a regular inequality, and I'll ask, is this point a solution? So then you just plug it in. All right. And honestly, it'll be multiple choice. So even if you don't know what you're doing, you got a 50-50 shot guessing it right. So there you go. But I recommend just trying to plug it in. All right, so graphing a system of linear inequalities. So we got 3 main steps here. Step 1, we're going to graph each inequality in the xy coordinate plane. We're just going to graph. We're going to graph both lines. Then you need to shade on the correct side of each boundary line. We don't need to test a point. That's something I used to do. We don't need to do that. That's a waste of time. But remember, if it's greater than or equal to, you shade above. If it's less than or equal to, you shade below. And then you find where these solutions overlap. Basically, we're going to shade, and we're going to see where our shading kind of like crisscrosses. That's why I like to use the 2 colors, because then it's kind of easy to see where your 2 colors overlap. All right. So I'm going to do some color coding for this. So I'll do one equation in one color and one equation in another color. All right. So for number 1, we got y is less than or equal to 3. So I'm going to do this first equation in this like purple color. So y is less than 3. Remember, this is one of those weird ones where it's either going to be a vertical or a horizontal line, because if you look on the right here, is there anything except that 3? It's just the 3, right? So if it's y is less than or equal to 3, where should I put my dot? Should I put my dot at 3 on the y-axis or on the x-axis? Anybody think they know? Yeah. I asked that since it's y is less than or equal to 3, do you think I should put my dot at 3 on the y-axis or the x-axis? Yeah, the y-axis, exactly. So put a dot at 3 on the y-axis. Now, if we drew a vertical line, isn't there already a line there? So we want to draw a horizontal line. Take a look at our inequality symbol. It's a less than or equal to. Am I going to put a dotted line or a solid line? Good, yeah, it's going to be a solid. Remember, when there's a line underneath it, use the solid line. So I'm going to put a solid line through 3. Wish I could use a ruler on here. All right, so there's my solid line. Okay, now I need to decide where to shade. This is less than, so remember, less than, we think smaller. Do you think our smaller numbers are going to be above our line or below our line? Below the line, very good. So we're going to shade below our line here. I'm going to use my highlighter. I like how that looks better. Oh no, except I erased my line. I got too excited. Okay. All right, so yeah, we shade below. All right, so now let's look at our other line. We got y is greater than x plus 2. So I'm going to do that one in pink. That one, it's going to have a slope. So like Dallas, I know you got confused on one of these on the homework, probably because it has a little less going on here. So remember, if you have an x and then a number, right, you're going to have your, you will have some type of slope here. So what do we graph first? Who remembers? Where should I put a dot first? Yep. What number is the y-intercept, Asia? I think you're looking at the wrong thing. You're looking at number 2. We're still over here. Yeah. 2, yeah. Here, I'll zoom in so we know exactly where we're looking. Yeah, so you're going to put a dot at 2 because that's what my y-intercept here is. So put a dot at 2. And then who thinks they know what their slope is? Well, so the 3 is only in this first equation. If you look at the second equation, there's no 3 in it. Yeah, if you take a look at this x, there's not really a number in front of it, right? So if there's not a number in front of it, it's technically a little invisible 1. Does that make sense, Alex? So you would go up 1 over 1. So we're going to go up 1 over 1, up 1 over 1. Remember, you can do that as many times as you want. Okay. Now take a look at our inequality. Do we think this should be a solid or a dotted line? Yep, this is a dotted line. Good. So put a dotted line going through there. Good. So dotted line. If it's a dotted line, well, so now we have greater than, right? So greater than, do I shade above the line or below the line? Above. Yeah, above. Very good. So remember, think of it kind of like a hill. If you're shading above, it's on top. If you're shading below, it's underneath. So we're going to shade on top of this line here. Okay. And if you take a look, I'll probably have to use a little bit darker of a color, but if you look in this little section right here, let me grab my highlighter again. I think I'm going to need to use darker highlighters. If you take a look over here in this little chunk, didn't your colors overlap? That means this little chunk where our colors overlapped, that's where our solutions are. That's where our answers are. So if I pick any point in this little shaded area, that's an answer. So like if I picked the coordinate point -5, 1, that's an answer. Like if I plug those in, they would work. But if I plug something in that's not in the shaded area, that's not an answer. Also, if I plug something in that's just in the, see how here, how I just have purple shading right here in this little bottom right section? That means it only works for the purple equation. Doesn't it have to work for both? So the only place where there's answers are where you have both pink and purple shading. If I pick a point down here, like 6, 0, that's not going to work because it only works for purple and not for pink. Okay, and for the next one, I'll do some brighter colors here so it's easier to see. And when you're graphing it on yours, I would just make sure you maybe, wherever you see your crisscrosses overlapping, like your shading overlapping, you can just go in and shade that a little darker so you can tell. All right, let's take a look at 2. So for 2, we have y is greater than or equal to -x plus 4. All right, so y is greater than or equal to -x plus 4. Who thinks they can help us out and tell us where our slope or where our y-intercept is? We're looking at this one. Y is greater than or equal to -x plus 4. Yep, put a dot at 4. Good. And then somebody else, what do you think our slope's going to be? I see this little negative in front of the x. What's that mean? So, so this part has to do with your slope. So Dallas, what I asked, I heard you ask what? Dallas, I asked like what the slope was. So remember, your slope is whatever number's in front of x, right? So technically, does anyone know what number would be in front of your x here? Yeah, a -1, exactly. So if I need to count out a -1, how could I do that? Yeah, very good. We're going to go down 1, right 1. Very good. All right. Let's see who else is here, because right now I can only see who has their camera on. So now, Mm-hmm. Correct. Yes. Yes. Yeah, so I would always try to keep it consistent. If it fits in your graph, Alex, if it's negative, I would try to go down and right, okay? And if it's positive, you go up and right. It's just nice because then you're always going to the right and you don't have to think about it too much. Did that answer your question? Okay. Let's see. So now we need to decide what kind of line we need. Lynn, what kind of line do you think we're going to use here if we have a greater than or equal to? Any idea, Lynn? You there? I'm not sure. Mr. Sander. Oh wait, Nick, I can see. Nick, you were raising your hand. It's the best day of my life. What do you think, Nick? It is a solid line. Yes, because we have the bar underneath. It is a solid line. As I was getting excited about you raising your hand, someone chatted me. Thinking I forgot what it. Lynn, my brain couldn't think of which one to say. Oh, okay. I was gonna say I'm not sure what you just sent me. All right, yeah, we need a solid line. Very good. All right, so here is my solid line. Now, refresh my memory. What's this mean? What's this symbol? Is this a greater than symbol or a less than symbol? It just, so is this a greater than or equal to or a less than or equal to? It's a greater than. Very good. I'm trying to make sure we know, because on your test, right, I'm not going to be there like telling you what the symbol is. So this is a greater than. Very good. So if it's a greater than, should I shade above or below? Above. Yep. And I say kind of like pointing above. Yes, we are going to shade above. All right. I'm thinking that the blue will be easier to see than the purple. All right. Now let's try this other one. Oops. What happened here? All right. So now this second one, we got y is less than or equal to negative x. Do you guys notice there's nothing added or subtracted on the back here, right? So I don't see a y-intercept. Well, if I can't see a number that's being added, does anyone know what that number is? Like if I can't see a number that's being multiplied, it's a 1. What if I can't see a number that's being added? It's a 0. So our y-intercept here is actually 0. So you're going to put a dot at 0. Good. No, I don't. I just like to throw a 1 with a y-intercept of 0 at you at some point, so you'll have seen it, you know. But no, I don't put it on my test personally. All right. So now, same idea though. Don't we still have a negative in front of this x? So someone refresh our memory. What's our slope going to be? Negative 1. So we're going to again count down 1 over 1. All right, and then somebody help me out. What kind of slope are we going to have? Or not slope, I'm sorry, what kind of line? Should I have a solid line or a dotted line? Yep, we're going to have a solid line. Very good. What do you guys notice about these two lines? Exactly, they're going the same way. They're parallel, right? These lines aren't going to intersect. Now, normally when you have two lines that don't intersect, there's no solution, right? Here it depends on the shading. So if you still have some shading that overlaps, there's some answers. So let's see. This is a less than or equal to symbol. So if it's a less than or equal to, Aaron, what do you think? If it's a less than, do you think I should shade above or below? Below, good. Aaron, the top of your head like blends into your chair. You're like a little illusion. Like I'm like, is that Aaron or is that just his chair? Yeah, we're gonna shade below. I think those colors are a lot easier to see. So if you take a look, does my shading overlap at all? Does that blue and that pink, does that overlap? If it doesn't overlap at all, are there any answers? No, so I would maybe make a note to yourself here. This is what no solution would look like with these. No solution. There's nothing that works for both. Okay? All right. I think we got a couple more. How are we doing so far? Okay, good. What about the rest of us? Are we there? Because I can only see some of us. Okay. All right. Yes, good. All right, perfect. Thank you. Always appreciate feedback. All right, number 3. We got y is greater than 2x minus 3. Y is greater than 2x minus 3. So, let's see here. Who shall I harass? Jaden. Hello, Jaden. You snuck into class. Jaden, what is my y-intercept going to be on this top inequality here? Maybe. So that's actually your slope. So remember, your slope is attached to the x, and the y-intercept is whatever's added or subtracted on the back. That's okay. So what number do you think? Okay, kind of a 3. What sign is in front of it? Yeah, negative. So no, that's okay. So we're going to put a dot at -3. Jaden, how is this going so far? Because I know you weren't here last class. Okay. All right, so now we need our slope. Remember, our slope is whatever's in front of our x. Mason, what's our slope? No, I'm not sure if Mason's there. Hannah, what's our slope? Okay. Maybe. Okay, I don't know. Hayden, what's our slope gonna be? 2. Yep. Hayden, how do you count out a slope of 2? Do you think I go up or down? Up. Up how many? Yep. Up to over 1. Exactly. Yeah. Because if you have a whole number, you got to think of like there's technically an over 1 at the bottom. Very good. So up to over 1. Good. Now we got to decide what kind of line we need. Dallas, what do you think? Should I use a solid line or a dotted line here? Yep, we need a dotted line. Good. I don't know. All right, so we got a dotted line, and now, is this a greater than symbol or a less than symbol? It's a greater than, good. Corey, if it's a greater than, should I shade above or below? Above, very good. Good. And remember, guys, I'm not calling on you to like punish you and be like, ha, I got you. Like it's simply so that I know if it's making sense, you know. So if I call on you and it's not making sense, tell me, because then we can fix it. Because if it's not making sense for you, then it's probably not making sense for someone else either. So now let's take a look at the second equation. We got y is greater than or equal to 1/2 x plus 1. What is my y-intercept? Jake Sanders, what's my y-intercept? You there, Jake? All right, I don't know what happened to Jake. Who else can I bother? I don't know. Nick. Oh, someone raised their hand. I can't see it though. Asia, what's my y-intercept? No. Sure. Oh, I hope so. I am. This is true. I'm sending out emails today. All right. So, for this one, Nick, what's my y-intercept for the 1/2 x plus 1? Yep, it is 1. So put a dot at 1. And now we got to count out our slope. We got a slope of 1/2. Jaden, how do you count out a slope of 1/2? What do you think, Jaden? Very good. Up 1 over 2. Good, good. Jake Sanders, I saw you left and came back. Were you having some mic issues? Oh, okay. Well, welcome back. Jesse, do you think I need a solid or a dotted line here? Solid, good. Oh, guys, that's a good line that I just drew. Look at that. All right, got my solid line. So now I need to decide if I need to shade above or below. Is this a greater than or equal to or a less than or equal to symbol? Anybody, greater than or equal to or a less than or equal to? This is a greater than or equal to, so anybody, shade above or below? Above, yep. So we are going to shade above. And take a look, that's why I picked some different colors. Can you guys kind of see where those colors are overlapping? All right, right here. I'm gonna go ahead and shade over it a little bit darker here so you can see a little better. The effect is better when I have like real highlighters and we're like actually like looking at it in person together. But see where it's like overlapping and making this weird little dark blue portion? That's where all of our solutions are. So if I pick any point in this dark blue shaded area, that is a solution to the system. So if I pick the point -2.5, that's right here, that's an answer. If I pick a point over here, like 8, -2, that's not an answer. There's no shading. Am I allowed to pick a point that's just in the pink shaded area? No, because it has to work for both, right? So I'm also not allowed to pick a point that's just in the blue shaded area. Right. Let's see where we're at here. We're running a little short on time. I want to look at, we're going to skip around a little bit. We're going to look at number 5, and then we're going to look at number 7, okay? And then we'll call it a day. I feel like we're doing pretty well with this because it's the same stuff. So for number 5, we got y is greater than x minus 1. So y is greater than x minus 1. Alex, what do you think my y-intercept there is? That's okay. What kind of a 1? -1. So put a dot at -1. And then there's nothing in front of my x here. So we have a slope of just 1. So count up 1 over 1. Lynn, should I use a solid or a dotted line here? Dotted, very good. We need a dotted line. And then this is a greater than symbol. Bailey, if this is a greater than symbol, should I shade above my line or below my line? You there, Bailey? Jaden, what do you think? It is above. It is above. All right. Good. Alex, did you say that Bailey's here? Oh, this is good to know. Ah. Good to know. All right. I like knowing who's here too, because then I can maybe come bother you guys in SRT. So then we have y is less than or equal to x plus 1. Y is less than or equal to x plus 1. So now for this one, Corey, what's my y-intercept? My y-intercept is 1, so put a dot at 1. And then I have a slope of 1 again, so go up 1, over 1. Aaron, does this one need a solid or a dotted line? This one needs a solid line. Good. Oops. There we go. And these ones are parallel again, but let's see if any of our shading overlaps. For this one, if it's a less than or equal to, should I shade above or below? Hayden says below. Do we agree? Alex says below. All right, below. And then if you take a look at that, did any of my shading overlap? I need to color it in a little darker, but doesn't it overlap here in this weird little middle portion? So this one, they were parallel, but there are some solutions there in that middle part because the colors overlapped. All right. Yeah, exactly. Like 0, 0 would work, 1, 1 would work, right? Anything in that little dark blue sliver. Good. All right, let's look at number 7, and then we are going to call it a day because number 7, we're actually going to check a couple points and make sure we understand when it's a solution or not. So for the first one, we have y is greater than negative 2x plus 3. So real quick, because we're running out of time, somebody tell me what's my y-intercept here? 3, very good. We got a dot at 3. What's my slope? Negative 2. Should I count up or count down? Count down 2, right 1. Down 2, right 1. All right, somebody else, solid or dotted line? Good, dotted. Dotted line. And then how do you read this? Is this a greater than symbol or a less than symbol? It is a greater than, so should I shade above or below? Above, very good. Shade above. All right. Now let's look at this second one. Something fell. All right, so now we got y is greater than or equal to? Y is greater than or equal to 1/2 x minus 2. Y is greater than or equal to 1/2 x minus 2. What is my y-intercept? Negative 2. What's my slope? Yeah, count up 1, over 2. Up 1, over 2. Solid or dotted line? Solid. And then this is a greater than or equal to, so do I shade above or below? Above. Very, very good. So now let's see. Do my colors overlap? Definitely. They overlap in this top right-hand portion here. So I'm going to shade that in a little darker so we can see it a little easier. So anything that's in this part is an answer. So let's practice identifying it because I'm going to ask you a couple of these on the test. So let's, I'm going to grab a different color here. So let's check and see. So is 3, 2 a solution? So you go up 3, over 2. That's falling right in there. That green dot. Is that a solution? Yes or no? Alex says yes. A bunch of people say yes. That is where both of my shading is. So that is a yes. Very good. All right. So we think B is not. So negative 4, negative 2. So that's right, or that's left 4, down 2. Yeah, I agree. Because isn't that only where the pink shading is? Oh, that orange is hard to see. Yeah, that's only where my pink shading is. So that one is a no. 0, 3. 0, 3. Ooh, 0, 3 is tricky. 0, 3 is tricky. It's right on the edge. Is it on a solid line or a dotted line? A dotted line. So if it's a dotted line, it's not or equal to, is it? No, so this one's actually a no. It looks like it could be. That one's a tricky. I don't think I ask any dotted line questions. That one, since it's on a dotted line, it doesn't work. What if it was on a solid line? Would that be okay? The solid line would be okay because that's an or equal to. All right, and then last one. I don't have another good color to use here. We'll use this weird silver. Is 6, 1 a solution? So 6, 1. Now my line wasn't very neat, but it should be on that solid line, right? Yeah. I just didn't do a very good job drawing my line there. But this one, it should be on it. I just didn't have a ruler. So this one is a yes. The ones that I ask you on the quiz, it'll be a little bit clearer. I'm not going to put it like on a line. I'll either put it in the shaded part or not the shaded part. Okay. All right. Do we feel okay about this? I feel like we're doing pretty well. Excellent. So you guys do have